we will determine the equivalent resistance when two resistors are connected in series, okay, using this Wheatstone bridge method. In earlier experiment, I have explained how to determine unknown resistance using this Wheatstone bridge method. Just we have modified that instead of this resistance X, that is unknown resistance, we have connected here two resistors in series. So these are the two resistors. One is connected, each other connected in series. So this is the series combination. And all of you know the series combination formula. That is R is equals to R1 plus R2. So using this experiment, we will determine what is the equivalent resistance in case of series. Okay. So first we will check. First what we will do? First we will choose P and Q. P is 10 and Q is 10. Like the previous experiment what we have done. So P is 10, Q is 10. Now I will connect. So let's choose, that is it is shows that along left side. It is now your R, that is the third arm, it is 0. Now let's say it is infinity. So infinity, it should show deflection along right side. Yeah, that means my connections are okay. So next choose what is the resistance value. So let's choose, it is 10 ohm. So 10 ohm shows deflection is along left side. Okay. So let's choose another thing. Let's say 15 ohm. So 15 ohm says it is along right side. Okay. So this is not actually the correct. That's why the resistance is not up to 10. Okay. So let's choose resistance value, that is 5 plus 2 plus 2, 9. So for 9, okay, for 9 it is shows that the deflection is along left side. Okay. So let's choose 10 deflection is along, deflection is along right side. That means when you choose 10 ohm, it shows your deflection is along right side, and when you will choose resistance is 9 ohm, that R, it shows along left side. That means your unknown resistance value is in between, it is in between 8 to 9 ohm. Okay. So we cannot choose any value in between 8 to 9 using this Q and P, that is 10, 10, 10, because there are no resistance like 0.5, 0.1 or 0.2. Okay. So next we will apply another process. Okay. What the process? Next process is we will choose Q is 10 ohm, P is 100 ohm. Okay. That means your X, using this formula, X is 10 by 100 into your R. Okay. So let's open this thing. Your P is 100, P is 100 and Q is 10. We will again choose for what values of this R, it shows null deflection. Okay. So look, for this resistance 9 ohm, it shows along left side. So let's choose another thing. Let's choose 100 ohm. Okay, 100 plus 9. So 109, it is along right side. That means your resistance is in between this 109 and 100. So let's choose 100 ohm. Now it is only 100. Okay. So for 100, it shows, see the deflection. The deflection is along left side. Okay. So for 100, it is left side. Let's say 110. Okay. 110. So see the deflection. So deflection is along. Deflection is along right side. Okay. For 100, it was left side. For 110, it is along right side. Okay. So let's choose another value, that is 110. Let's add some 115. Okay. So for 115, it is along right side, but the deflection is more. So it is not 115. So let's check again for 110. For 110, yeah, 110 it is along right side, but the deflection is very less. Okay, so let's check for 107. Okay. For 107 it is along left side. For 107 it is along left side, and for 110 it is along right side. That means your resistance is in between 107 to 110. So 107 to 110 we can choose 108. For 108 it is along, yeah, it is along right side. Okay, let's check another thing. So 108, let's check 109. For 109 it is along right side, but the deflection is more. So the correct resistance choosing, that is value of R, we can choose using this thing, that is, yeah, it is almost 100. Look this, 100, here it is 5, 5, 1. It means 100, 5 plus 2 plus 1, 108. Okay, so using this Q and P value, we can choose that R value is 108. Okay, so your unknown resistance is 10 by 100 into 108. That means 10.8 ohm. Okay, so this is exactly not at 10.8, since there are some kind of deflection. Okay, so it should be zero deflection. Okay, zero deviation, but it is not zero. So look this thing, the pointer is, okay, so the pointer is moving. So it is not exactly null condition. Okay, so we will determine null condition using the same principle, that is, we will choose the Q value is 10 and P value is 1000. Okay, your Q is 10 and P is 1000. So in third case, your X will be 10 by 1000 into your R. Okay, so we have to choose what is the value of R. Next we will do the same thing. Okay, so first start from beginning. So yes, for 0, no, not, it is not 0, now it is 0. For 0, okay, so the third arm, that is, it should be closely connected. Now the third arm, it shows it is 0 resistance. Okay, so 0 ohm. For 0 ohm, deflection is along left side. Okay, now we will, for infinity, it will be, yeah, it is along right side. So your unknown resistance, it is unknown value of R, is in between 0 and infinity. Okay. So we will choose, let's say it is 500. Okay, for 500 it is along left side. Okay, next choose another thing, let's say 700. For 700 it is along left side, but the deflection is less compared to 500. That means we are going in right way. Okay, so let's choose another thing, that is 900. So see, for 900, yeah, the deflection is around left side, but it is less compared to 700 also. That means we are in right track. Okay, next we will open this 1000. Now 500, 200, 200, 100. That means 1000. So for 1000, it is along left side, but the deflection is less compared to 900. Okay, so we will again choose 50. Okay, 150. So for 150, yeah, so deflection is very less. Okay, we will add again 150 plus 50. Okay, so 170. Okay, sorry, 1070. It is along left side. Okay, 1090. Okay, 1090. It is along left side, but the deviation, the deflection is very minimum. Okay, again we will add plus 10. We will choose. Yeah, now we are almost at null deflection. So we have to choose in such a way so that this pointer will not move. Okay, now it is moving, but the movement is very less. Okay, so let's add another resistance. Let's plus 5. So for plus 5, yeah, almost we got the deflection. Okay, we got the null deflection condition. Let's add another thing. Yeah, so Yeah, so this is the R. So now we will calculate what is the R from this. R is 500, 200, that is 700, 900, 1000, 1050, 1070, 1090, 1100, 1107. Okay, so 1107. So your R value is 1107. So what is your unknown resistance? Unknown resistance is 10 by 1000 into 1107. If you simplify it, it will be 11.07 ohm. Okay, so this is the experimental value of this two resistance when they are connected in series. Now look this, they are connected in series. Okay, so what does the theory says? Theory says R equivalent is equals to your R1 plus R2. That means 5 plus 5, that means 10 ohm. And experimental value is 11.07. That means your experimental value is very close to your theoretical value. Okay, so this is the experiment of unknown resistance determination and what is the value when the two resistors are connected in series. Okay, so okay.